Hello, my name is Chen Yi. Today I would like to talk about my LEGO robot Mind Follower. This is the outline of my talk. The first one I want to introduce is our robot. It has only one photosensor which can detect the intensity of reflected light. If the robot is on the black place, the feedback signal will be low. For the white place, it is opposite. The robot has two wheels which are connected to the two motors, left and right. A rear-driven wheel is also applied. For the turning, it depends on the differential steering. Actually, the robot will follow the line between the black place and the white place. So why not follow the fat black line? This is because when the robot drifts off, we cannot determine which side of the fat line it is. Before we go through our steps and strategies, I want to explain this coordinate system. The x-axis is the arrow, which equals to the current feedback signal minus the error signal from the black place and the white place. And the y-axis is the turn, which equals to the difference between the power of the two motors. We have 6 controllers: 2 level, 3 level, proportional with arrow range, improved proportional with arrow range, and proportional integral controller. First is the 2 level. The basic form is to distinguish the black place and white place with a certain feedback signal, and the robot will chatter along the line suggested by this graph. However, our 2 level is like this one. What we saw was that if the robot could have 2 times of correcting the second and the third situation, it could be relatively steady. However, further analysis suggests a problem. We cannot figure out which line the robot is following now. It may follow the line with a feedback signal of 20, but it may also move to the area with the signal less than 10. But it did suggest us a way to reduce the chattering. That is the 3 level. This is the program, and this is a screenshot of it. You can imagine the y-axis is the target line. If the robot is on this one, the white place, it should turn left to back to the line. If it is on here, it's on the black place, so it should turn right. And if the robot is on here, it will move straight. Here's the video of our 2 level.
这块已经飞了。
And this one is the 3 level. These pictures are from the videos. So what's the difference? We admit that the difference is little, and we may need some facility to measure it. However, the speed of the robot, the 3 level robot, is higher than that of the 2 level robot. Since it is difficult for a robot with higher speed to be steady, the 3 level is better. Actually, both of them have a problem. That is, the robot can only turn in a certain degree. In other words, even if the robot only needs to have a small turn, it will have a big turn, so it may drift off. So the solution is the proportional controller. On the left is our program. Before every test, the robot will collect the feedback signal from the black place and the white place. Actually, it's the black tape and the white floor. This is to offset the interference of the room light. However, this program cannot correspond to this graph. This is because this part, the things in the brackets, is not the error. So the correct form should be this one. The power of the left motor equals to 30 plus 2 times of the error, and the right motor equals to 30 minus 2 times of the error. This is the video when the fundamental speed is 0.
开始，
This is when the fundamental speed is 30. Oh, sorry. First, I compare the 3-level robot with the proportional robot when the fundamental speed is 30. From the pictures, we can find that the proportional one is better. For the reason of it, the 3-level robot can only turn in certain degree, which is rigid, but the proportional one can turn in different degrees according to its position, so it's flexible. And second, I compare the proportional robot with different fundamental speed. The slower one, the fundamental speed is 0, is better. So why that is? This is because it has a lower speed, so it will have a smaller displacement in one step, and it will be closer to the line in the one step. Actually, it has a problem. The robot can only have a very, very short time of moving straight, which will limit the speed. So the solution is the error range.